Hey there, welcome back to the Unit 3 Fall Review. I'm going to do problems 6 through 10 using the Ti-Nspire. So in this problem right here where we're going to describe the transformation, what I want you to do is just type this into the graph, the absolute value of x. So open up a graph page. I'll type in the absolute value by pressing this button to the right of the 9, and I find the absolute value bars right there, and then I just type in x. So that's my parent function. So I need to see the transformations, right? So I have a 5 here doing something, a -3 doing something, and a +4 doing something. So what I recommend doing is typing them in one at a time. So I'll type in 5 and then absolute value of x. Just that. All right. So I see that and I see that it's getting skinnier. That's called a vertical stretch. So I'll write that down, vertical stretch. All right. Um, you might even see it say vertical stretch by a factor of 5, but yeah. So now let's talk about what the -3 is doing on the inside. So I'll hit tab and I'll go back to it and I'll just type in a -3. You see it goes right 3. So I'll put right 3. And then the +4, if you don't know what that's doing, just type in the +4 now, just add it in, and you see it shift up. It may be hard to count, but you can kind of gather that it went up 4. Now, there is a way to show grid lines on here. If you go to menu, view, grid, and then line grid, and then it might be easier for you to count. But I mean, +4 and it went up, you can kind of gather that it went up 4. So yeah, that's everything to do for any transformation. That's the easiest way to go about it, I think. Now for number 7, we're going to use the graph again. So I'll go to a new graph page, and then I have 3 times the absolute value of x plus 1/2. So 3 absolute value x plus 1 over 2. I'll graph that, and then it's going to equal -4. So hit the tab button, and what's happening? Tab, type in -4, and you see they don't intersect. Okay, so therefore, it's no solution. Um, and that's number 7. All right, so number 8, we're going to type in 5 minus 3 times absolute value of x minus 2. 5 minus 3, absolute value, x minus 2. And then what it equals goes on a different line. It equals -7, so I'll type in -7. And so I need to zoom out because you see it goes to -6.67. So menu, window zoom, zoom out, click right there. Then do menu 6, 4. Click, highlight, click, menu 6, 4. Click, highlight, click. Those are my two answers. So x equals -2 and x equals 6 are the two answers. X equals -2 and 6. All right. So number 9 and 10 are inequalities. Those are a little different. So if you type it in as a relation, I believe you get an error message. So I'm going to type this in. By the way, if you hear a bell ring, that means the bell's about to ring at school. So just letting you know it's about to come. So I have x minus 4. And then I'll type in control equals less than 12. And you see how it says it's not supported. So what I recommend doing is this. Just don't even bother trying to type it in as a relation. So go to add graph and then just type in, the left side and the right side. So 1 over 3, and then absolute value of x minus 4. And then it's supposed to equal 12, right? Or less than or equal to 12. So we have that. So I need to zoom out again because it only goes up to 6.67. So menu, window 4. And then I'll zoom out, make sure I can see both intersections. Okay. So what I'm going to do is I'm going to go to Analyze Intersection, menu 6.4, click, highlight, click, and menu 6.4 again, click, highlight, click. And so since this is an inequality, you don't say the answer is -32 and 40. You need to plug in a number. Is it going to be, is x going to be less than or equal to 32, or greater than or equal to -32? So these are your two boundary points, right? pick a number in between these two numbers. So pick the number 5, for example. I'm going to plug in the number 5 into the, there's that bell. So 1 over 3, I'm going to plug it into the original. So I picked 5, right? So I'm going to do 5 minus 4. And then if you want, you can even finish the whole thing, put less than or equal to 12. So that's a true statement. The point of doing that is by picking a true statement in between these, I know my answer is going to look like this. Insert equation. I'm going to put negative 32, and then I have my less than or equal to x less than or equal to 40. If it was false, it would have been going in the opposite directions. It would have been an or statement. So let's see number 10. Let's see if that turns out to be a false one to give you a good example. So I'm going to go to add graph, and I'm just going to do, what was it, x minus 7. And then I'm going to go to number 5, and I need to zoom out a little bit. Hopefully it's not too noisy. Click, highlight, click. Menu 6, 4, click, highlight, click. So it's between 2 and 12. So let's pick a number between 2 and 12. How about 8? All right. So my problem will say 8 minus 7. So absolute value of 8 minus 7 is that hit control equals greater than 5. That's a false statement. So that means since I picked a number in between them, I'm going to shade on the outsides. So I'm going to shade less than 2 and greater than 12, right? So I'm going to say x is less than 2 or x is greater than 12, okay? So that's the whole point of plugging something in. So sorry the calculator can't tell you that specifically, but it's just a little extra work, and it is, some people find it easier to do that than solving it by hand. So thanks for watching, and goodbye.